Alright guys, this is the math review for the Algebra 2 Honors Final Exam. And I was given number 8, 12, and 14 on page 597 for the extra credit assignment. So the first problem I'm going to do is number 8 on page 597. And I apologize for any handwriting or mistakes I made because I am writing this on my iPad, so it is not going to be perfect, but I will try my best. So the question it was asking me to do is identify the zeros and the vertical asymptotes of each function and then graph them. So my starting equation was x squared minus x minus 12 over x, and I'm going to find the zeros is the first thing I'm going to do. So I'm going to factor this, the top right here, which is going to leave me with x minus 4 and x plus 3 over x. And this right here is where I'm going to get my zeros from. So if you remember, all you have to do is set them equal to 0. So x minus 4 equals 0 and x plus 3 equals 0. And you just solve that, getting x equals 4 and x equals negative 3. So this right here is going to be our zeros of the function. Alright, and then the next part is finding the asymptote, and for rational functions, the vertical asymptotes are the undefined space. And you can see this in a graph, and I will show you a graph. And I'm just going to put the main points on here so it's easier to read. So this first line is going to be coming up here, and then it's going to cross at 4. Continue going that way. It's going to kind of go up and over like that. And then the next one is going to be coming up this way, and it's going to cross at negative 3 and keep going that way. So then, as you can see, this is our 0 because 0 is that line. And as the functions get closer and closer, as they keep going up, they're going to get super close to 0, but they're never going to actually touch 0. And that is the same with this line right here. It's going to keep coming down, coming down. It's going to get super close to 0, but it's never going to actually touch 0. And that is what makes the vertical asymptote equal 0. So that is the final part of this problem. So there we have our 3 answers. The zeros are here, here, and the vertical asymptote is here. Alright, now moving on to question 12 of page 597. And it asks you to identify the zeros and asymptotes of each function and then graph. So the first thing I'm going to do is get my starting equation, which is x minus 2 over x squared plus 6x. And I'm going to be factoring the bottom this time, which is going to leave me with x minus 2 over x plus 6. And then the 0 is going to equal 2 because the numerator is equal to 0 when x equals 2. And to explain that for you, going to do the same thing we did in our other problem. X minus 2 equals 0, x equals 2. So this right here is going to be our 0 of the function. And then the next thing we do is find our asymptotes, and the vertical asymptote is going to be 0 and negative 6, and you're going to get that answer because the denominator is equal to 0 when x equals 0 and x equals negative 6. And I will show this out as well. So you're going to be taking this part right here, and this part right here. And then take it there. So x equal to 0. So that one's already done for you. And then x plus 6 equals 0. So you have to move the 6 over, so you're equaling x equals negative 6. So this right here is giving you the vertical asymptotes is 0 and negative 6. And the very last thing is the horizontal asymptotes, and that is going to be y equals 0 as x reaches positive or negative infinity. So you show that as y equals 0 as x approaches positive or negative infinity. So that right there is going to then give you the horizontal asymptote. And it's like that because of the degree of the denominator is more than the numerator. So that is why we have to do this reasoning and logic for the horizontal asymptotes. So right here, this problem is going to give you the zeros of the function are 2. The vertical asymptotes are 0 and negative 6. And this right here is the horizontal asymptotes. So that is all for that problem. And then our very last problem is going to be number 14 on page 597. And the directions for this one read, identify the holes in the graph of each function and then graph. So again, the starting equation is f of x equals x squared minus 5x plus 6 over x squared minus 4x plus 3. And you're going to factor both the denominator and the numerator, because both of them are able to be factored out. So then you're going to get f of x equals x minus 2 x minus 3 over x minus 1 over x minus 3. And x minus 3 is a factor of both the numerator and the denominator. Therefore, the whole is going to be at x equals 3. And you can see that right here, because they are both that. So you can do x minus 3 equals 0, and you're going to get x equals 3. So this right here is the whole in the graph is at x equals 3. And then to find the graph, or to make the graph, you're going to go back to your equation of f of x equals x minus 2 x minus 3 over x minus 1. Oops, that should be a negative. X minus 1, x minus 3. You're going to cancel out the common denominators, which is x minus 3, x minus 3. So when you cancel those out, you just get x minus 2 over x minus 1. And then we're going to graph that. And you can, to graph it, you can just graph this, the simplified part, and the only thing different about it is going to be that we're going to add in the whole at negative 3. And we can do that as we're graphing it. So you can plug this into your calculator as well. And I'm just going to show it on here because, again, I do not have a calculator on my iPad to show you the actual picture from the calculator. But this right here is going to be the one that goes through. I'm going to go over and up. And this one right here is going to be coming this way. Go over, and then there's going to be the hole at 0. And holes are indicated with an open circle. So make sure you do put that in your graph when you're making it. And it's going to go this way. So this right here is how you show the hole that is at 3. And that right there was all of problem 14. And going back through it, you can see where the hole is at. And then the hole being graphed down here. So that is all for my math review video. Thank you for taking the time to watch this, and hope you have a great rest of your day.